Let's take a look now at section 1.4 and talk about quadratic equations. A big part of this course will be solving equations for the purposes of either finding their solutions or for the purposes of graphing or for the purposes of solving some application problems. In any event, solving equations shows up a lot. One kind of equation that shows up more than just about any other is going to be the quadratic equation. Partially because it's ubiquitous in a lot of applications, but also because other types of equations will eventually break apart into smaller pieces, and in a lot of those cases, the quadratic equation will be one of those pieces. So let's take a look at how to solve a quadratic equation with a few different methods. Now you might say, why do I need several methods? It's not that you need several, it's that, well, depending on your situation, one may be much simpler than the other. So it is beneficial and it's a useful thing to have several ways of solving something. In case one happens to be hard, well, you can fall back on another one, which is going to be simpler. So let's begin by just reminding ourselves of the one that we've seen before, and that's factoring. In pre-algebra classes, factoring is done, well, pretty much to death, right? You've seen factoring a few different ways, and the purpose of factoring is to break apart an equation into the product of smaller pieces. So here, let's just go ahead and begin the section by reminding ourselves of what factoring looks like. Once we remind ourselves of that, we'll go ahead and look at some other new ways of solving a quadratic equation, which, depending on our situation, may be simpler or not as simple as factoring. So whenever you have an equation like this, x squared plus 5x plus 6 is equal to 0. You can take this equation, you can take the polynomial that's on the left side of the equation, and you can factor it out. Whenever you factor something that looks like this, x squared plus a number times x plus a number, you can factor that out by saying x times x, like that, because of course x times x is going to give you x squared. What you need now are two numbers that, when multiplied together, give you that number 6. Those same two numbers, whatever they are, should add together to give you that coefficient there, that number 5. And of course, those numbers are 2 and 3. 2 times 3 give me 6. 2 plus 3 give me 5. So 2 and 3. All right, well, now that I've broken this apart into two smaller pieces, I can now say, well, the product of these two things is equal to 0. This times this is 0. Well, then, if I multiply two things to give me 0, one of these has to be 0. Because if they're both positive, the product of two positive numbers would be positive, not 0. If they're both negative, well, the product of two negative numbers is positive, not 0. And if one's positive and one's negative, well, then I get a negative answer. Again, not 0. So if the product of these two things is equal to 0, at least one of these needs to be 0. So we can set each one equal to 0 on its own and solve each of those. Notice that by factoring, we've gone from having one large equation to two smaller ones. And of course, that's always been the benefit of factoring, because now I can go ahead and solve each of these equations. Here I'm trying to get the x by itself. I'm trying to isolate my variable. Isolate the variable means get the variable by itself. And if I subtract 2 from both sides, that'll get me x equals to 0 minus 2 is negative 2. All right, this is a solution. Over here, I can do the same thing. I can say I'm going to subtract 3 from both sides of my equation. That goes away, right? 3 minus 3 is 0. Leaves me just the x by itself. And on the other side of the equation, I have 0 minus 3, which is negative 3. Oops. Negative 3. And this is also a solution. Okay? Things like that. So factoring is a way of getting our equation broken apart so we can find our solutions. This only works if I can find those two numbers, though. This only works if I can say, okay, look, 2 times 3 is 6 and 2 plus 3 is 5. But what if those weren't nice, simple numbers? What if this was 5 and 7? I can't think of two numbers that multiply to give me 7 and add up to give me 5. That doesn't mean there aren't any, but I can't think of any. We can make it even harder by introducing some fractions. What if I said this was 5/3 and this was 77 over 12? I could make things even harder by introducing an irrational number. I could say the square root of 5, and over here I could say 6 over 7. And in that case, I still have a quadratic equation, but this isn't going to work for me. I don't really know what numbers it would take to make that work, but I know it's not something that's going to be simple. So in this section, we're going to see how to solve equations where factoring isn't the best choice, or in some cases, not even a choice at all. So before we do that, let's go ahead and make sure we know exactly what we're talking about. A lot of times people will say, oh, I have my solution, and they won't quite say exactly what that means. So here, in the interest of being precise, let's go ahead and define a few things. So definition. First of all, we're going to be talking about quadratic equations in this section. A quadratic equation is an equation that looks like this. So we're going to let A, B, and C be real numbers. You say real numbers. Well, what else could they be? Well, they could be complex numbers. There is such a thing as a polynomial with complex coefficients, but we're not going to worry about that just yet. Right now, we're going to say let these be real numbers, whole numbers, fractions, decimals, but no imaginary parts. Let those be real numbers where A is not equal to 0. These could be 0 if you want, but definitely this one should not be. Then a quadratic equation and that's what we're defining. We're defining quadratic equation. A quadratic equation is an equation of the type ax squared plus bx plus c equals to 0, where x is a variable. A couple things to note. One, x doesn't have to be the variable, meaning I could use a different symbol here. X is very common, but we could say y or z or w or any other letter we like. X is common enough, though. You'll see that more often than any other. The other thing to note is that if this is written slightly differently, it still qualifies as a quadratic equation. Meaning, if I change the order of a few things, for example, if I put the c at the front and I write this as c plus ax squared plus bx is equal to 0, that's okay. Same thing if I take one of these terms and move it over here. If I were to say ax squared plus c is equal to negative bx, that's fine too. All right? As long as you have these kinds of terms in an equation, that's a quadratic equation. If you change the order of things a little, that won't change what type of equation this is. So the way you really want to look at this is, look at this thing right here, x to the second power. If you have an expression, x to the second, that's an indication of it being a quadratic equation. If this is an x to the third, fourth, fifth, or sixth, well, that power is too big. But if this one wasn't there at all, well, that would be a linear equation. You wouldn't have a second power. You wouldn't have a quadratic term. So a quadratic equation is an equation of the type, something that can be written as ax squared plus bx plus c is equal to 0. So for example, 3x squared plus 5x plus 12 equals to 0. One thing to note, this does need to equal to something to be an equation. This is called an expression, but when it's equal to something, that's an equation. All right? Note these constants can be anything we like, as long as they're real numbers. So we could say 5x squared plus 2/3 x minus 7. All right? You can have them be positive or negative. You can have them be fractions or whole numbers. Or if we like, we can even have a decimal. We can say 0.7 is equal to 0. And that would also be a quadratic equation. And again, we can always move things around if we like. We can write this as 5x squared is equal to 2x minus 3. That would also qualify as a quadratic equation because, of course, here we can move these over to this side and rewrite it so that it looks like this. And in fact, we can do that. Let's subtract the 2x over, 5x squared minus 2x, and let's add the 3 to both sides. So plus 3 is equal to 0. So even though it doesn't start off that way, it can be written that way. The other thing we want to define, let's make sure we understand what the word solve means. You say, well, I know what solve means. It means find the answer. Well, In math, it's a little more specific. Whenever we find an answer, there's different kinds of answers. A solution is not just an answer to a problem. A solution is actually a specific kind of answer. So, definition. Oh, actually, let's say it this way. That would have been redundant. A solution to an equation, and that's what we're defining. We're defining solution. A solution to an equation is a number or set of numbers. You can actually have more than one, or set of numbers that when substituted for the variable of an equation, make a true statement. Okay. That's what we mean by a solution. Going back to the original problem that we saw up here when we factored, this is an equation. X is some number which we don't know. We could plug anything we like in there. And we literally could. We could just plug in anything we like. I could say 10. All right, let me plug in the number 10 in here. I could say 10 squared plus 5 times 10 plus 6. Let me do that. 10 squared plus 5 times 10 plus 6 is equal to 0. All right? So I can plug in the number 10. The problem is that's not true. Because look, 10 squared is 100. Plus 5 times 10, well, that's 50, plus 6. And here that's 156. 156 is equal to 0. No, it's not. So here, this is false. I can plug in whatever number I like. I can plug in 10, 100, negative 73, any number I like. But the problem is, when I choose most numbers, I get something which is false. I get nonsense. 156 is not equal to 0. However, if I plug in a solution, let's see what happens. If I have negative 2 squared, right, plus 5 times negative 2 plus 6. Well, let's see. That's negative 2 squared. That's positive 4. Negative 2 times negative 2 is positive 4. 5 times negative 2, that's negative 10 plus 6. Right? That's 4 minus 10 is negative 6. And then negative 6 plus 6 is equal to 0. Oh, yeah, that works. If I plug in most numbers, I get something that's false. But if I plug in a solution, I actually get a true statement. That's what a solution means. It means, okay, I could plug in any number I want, but most of the time, the number that I plug in gives me something that's not true. When I get something that is true, that's a solution. Right? So just be mindful of that. The word solution doesn't mean answer, right? Solution means a specific kind of answer. A solution is a number that if we plug it into an equation, gives us a true statement. That actually helps us to verify whether or not we have the right answer. Whenever we look for a solution to a problem, you can always check that it's right. If in the end your solution is 4, well, go ahead and plug it in. If it makes both sides of the equation equal, well, then it was a correct solution. If not, well, then it wasn't. So let's take a look now at some other techniques besides just factoring. Because again, factoring has been done to death. You've seen that all the way since pre-algebra. You see that in high school algebra classes, right? So let's go ahead and take a look at some more advanced methods. This next technique is going to look a little limited. It's going to look like, okay, yeah, it works, but we're probably not going to see that except maybe once or twice ever. But it turns out to be the basis of something else. Meaning, yeah, the way it's going to look at first looks very, very limited, but it turns out that if we combine it with some other stuff, it actually is very useful. So let's go and talk about extracting the square. Okay, so extracting the square is a technique for solving a quadratic equation using a square root. Oh, let's see, I seem to be out of focus here. Let's see if I can focus the camera a bit more. Oh, that seems to have gotten worse, huh? Okay, that's a little better. Yeah, that's about as good as we're going to get. Okay, so extracting the square. Let's consider a problem that looks like this. Let's say I have x squared is equal to 9. Let's keep it very, very simple just for now. All right, one way to solve this is I could use factoring. I could say, all right, look, get that 9 over by the x squared. So let's go and subtract 9 from both sides. That'll make one side equal to 0, which is what we want when we're factoring. And we're going to have a polynomial on the other side. Now, x squared minus 9 is equal to 0. And now that's the difference of squares. All right? What do you square to get x squared? Well, you square an x. What do you square to get 9? You square a 3. So you stick a plus in one and stick a minus in the other. All right? So here, this is the factorization of that difference of squares. Okay, but now using the fact that the product of these is equal to 0, we can now say, well, I know for a fact that means either the first one's equal to 0 or the second one is equal to 0. And I can solve. Here I can say, okay, add 3 to both, subtract 3 to both sides here. So minus 3 and minus 3. For this one, I could say add 3 to both sides. Makes those go away. And now here I have x by itself is equal to 0 minus 3, which is negative 3. On this side, I have x by itself equals 0 plus 3, which is a positive 3. And those are my solutions. I have positive 3 and negative 3. Let's take a look at that same problem with a different technique. This is called extracting the square. All right, I have x squared. Yeah, but I don't want x squared. I want just x. Okay, well, whenever I want to get rid of something, I use its opposite. All right, to get rid of addition, I use subtraction. Here, this plus, I get rid of it using a minus. To get rid of subtraction, I use addition. So over here, I have a square that I want to get rid of. So let me go ahead and take the square root, the opposite of the square. This gives me x squared square root. Oh, well, those just go away and leaves me just an x all by itself. Over here, the square root of 9. What number can I square to get 9? Well, I can square the number 3. Well, wait a minute. That's not the only number, though. Yeah, 3 times 3 is 9, but also negative 3 times negative 3 is also 9. In fact, that pattern always works. If I can square a number to get a result, squaring the negative number will get me that same result. Meaning, if I can square 3 to get 9, negative 3 gets me the exact same result. So here, I'm going to get this answer, but in two different versions. One will be a positive version, and one will be a negative version. Right? We write that together. This symbol is usually read as plus minus, and it's just there to remind us that, yeah, we have an answer, but it comes in two versions, namely a positive and a negative. Notice, that's a lot shorter. Take the square root of both sides. Note that whenever you take a square root of a number, there's going to be two different versions to that. So here I'm going to write that as plus minus in front of the square root. There's going to be two different roots to a number. Two different square roots to a number. Here, note that this actually means two different things. It means x is equal to positive 3, and separately, x is equal to negative 3. This will be important later. Namely, this isn't one answer. It's two answers. And those two answers are going to be used for different things later on down the line. Notice that's a little bit shorter and just a little bit simpler than having to go through all of this process. This becomes even shorter the longer the problem gets. Let's take a look at some more examples. Let's do one more just like this, where I have x squared is equal to 25. And again, if I'm trying to get rid of that square, I can use a square root. All right, so square root of both sides. But remember, whenever I take a square root, I'm going to have two different answers. I'm going to have a positive square root and a negative square root. So that's going to give me x by itself is equal to both positive and negative the square root of 25, which is just the number 5. And that's it. We're done. X is equal to 5 or x is equal to negative 5. It's okay to write it as plus minus 5. Most people prefer it that way. It's less to write. But do keep in mind this is two separate answers. This means x equals 5 and x equals minus 5. And this will be important later. The fact that there's two answers is an important thing down the line. Okay? Now, this and this don't have to look exactly this way. You don't have to have just x squared. You don't have to have just a perfect squared number there. As long as you have something squared here equals to a number here, you can still extract the square. So, for example, let's say I have x squared is equal to 8. You say, well, that doesn't work anymore because 8 is not a squared number. Well, sure it is. It's just not a perfect squared number. Meaning, sure it is. It's just not going to be a very nice number. Here, to get rid of that square, I can use a square root on both sides. Remember, there's two roots, a positive and a negative. So here I get x all by itself equals to plus or minus the square root of 8. And you say, well, what's the square root of 8? Well, it doesn't have a perfect square root. We can simplify, though. In a previous section, we reminded ourselves of how radicals get simplified, and here we'll see it again. Notice that 8 is 4 times 2, and since 4 is a number that I know how to take the square root of, I can clean that up a bit. That's going to be plus or minus the square root of 4 times the square root of 2, and I know the square root of 4, that's just the number 2. So plus or minus 2 root 2. And there we go. There's our, there are our solutions. Positive, in fact, let's write them as two separate answers. X equals to positive 2 root 2, and separately, I have x equals to negative 2 root 2. And these are my solutions. Notice that wouldn't have been very nice with factoring. For factoring, I have to find two numbers that multiply to give me something or add up to give me something. Here, I didn't have to do any of that. Here, this number would not have been very nice to work with. But by extracting the square, I don't have to work with it that way. If this is not just an x, that's fine. Again, as long as you have something squared. So for example, let's say I have 2x plus 3 quantity squared is equal to, let's say 16. Okay, well, that is not just x squared. Well, so what? It's something squared. And to get rid of that square, I can use a square root. So let's go ahead and do that. Whenever I take a square root of a number, I have two different roots, positive and negative. So let's go ahead and don't forget that. Here, the square root of 2x plus 3 squared will just give me 2x plus 3. Over here, plus or minus, the square root of 16, well, that's just the number 4. Now, I haven't solved yet, because notice I haven't isolated my variable. I don't have x equals something. But now, without a square there, or without a square root there, things are a lot easier to work with. I can subtract 3 from both sides. That goes away. It leaves me just my 2x. Now, right here, I'm going to write negative 3 first, and then plus or minus 4. There's a reason I do that. Here, the plus or minus applies to the 4. This negative 3 isn't plus or minus. I don't have two different versions of this number, only this one. So I'm going to write this one first, and then this one second, because otherwise, if I have plus or minus 4 minus 3, it's going to look like the plus or minus applies to all of this. All right? Here, it becomes a lot clearer that, okay, look, the negative is there, and these apply only to this one. So this is done for the sake of clarity, to make things a little bit more obvious what belongs to what. And finally, we're going to divide everything by 2. Whenever you divide on one side by 2, you got to do the same thing on the other side. We're going to divide everything by 2. And so this gives us x is equal to negative 3 halves plus or minus 4 divided by 2 is just the number 2. And I get my result. Here I have x is equal to, I'm going to write it as two separate answers. X is equal to negative 3 halves plus 2. All right, that's negative 3 halves plus 2. On the other hand, I can also have negative 3 halves minus 2. All right, negative 3 halves plus or minus 2. And notice that here I can even simplify those a little bit further. Here I get x is equal to negative 3 halves plus 2. Well, that's going to be 1 half. And I can have negative 3 halves minus 2. Oh, well, that's negative 7 halves. Just like that. All right? So here, my two solutions to my equation are going to be 1 half and negative 7 halves. All right, so here, give this a try. Go ahead and use this technique. Go ahead and extract the square to solve the following equations. Let's have one nice and simple with just nice simple numbers. We're going to have x squared is equal to, let's say, 36. Let's have one slightly more complicated. Let's say x squared is equal to 24. In fact, let's say negative 24. Remember complex numbers. And then finally, go ahead and try this one. Let's see. Let's do 3x minus 1. The whole thing squared is equal to, let's say 5. Okay, go ahead and pause the video. Go ahead and find the solutions to these equations, and then once you're done, unpause the video and we'll go through it together. All right, so let's go through these. I'm going to go ahead and take the square root of both sides of my equation here. Remember, when you take a square root of a number, you have two different roots, a plus and a minus, just like that. And since I actually know the square root of 36, it's just the number 6, and go and clean that up a bit. So that's going to give me x is equal to plus or minus the number 6. You can leave that as plus or minus, but keep in mind that actually is two different answers, positive 6 and separately negative 6. And there we go. Nice and short. This one's slightly longer because, yeah, I can take the square root of this side and just get rid of the square, but now taking the square root of this side is going to take just a little bit of work. Now remember, there's two square roots, one positive and one negative. So that's going to give me an x right there by itself is equal to plus or minus the square root of negative 24. But now I can go ahead and simplify that out quite a bit. Here that's going to be plus or minus the square root of, well, let's see, I can write this as 4 times negative 1 times 6. But of course, that means that I can write this as plus or minus the square root of each one of these on their own. The square root of 4, separately square root of negative 1, separately the square root of 6. So what that means is I can take the square root of this one and this one to simplify. So in the end, I get x is equal to plus or minus, square root of 4 is 2, the square root of negative 1 is I, and the square root of 6, well, that one doesn't simplify. So that's just going to stay as root 6. And this is just like we see in section 1.3, where we can simplify out our imaginary number. And that's, now you see why we wanted to do that first. In section 1.3, to learn how that factors out. So there is our set of solutions. There's two of them, plus or minus 2i root 6. The fact that you have an imaginary number and a radical doesn't change that. You pretty much just take the square root of both sides. The third one, well, again, I can take the square root here and the square root here. That's going to give me 3x minus 1. On the other side, I get the square root of 5. I can't simplify the square root of 5. It's not a perfect square, nor does the number 5 factor anymore. Oh, well, then just leave it as the square root of 5. Just like that. Remember, there are two different roots there, plus or minus. And I'm saying that to myself just as much as I am to you. I forgot that myself. And now we can go ahead and isolate our x. Let's get rid of that minus 1 with a plus 1. Again, for the sake of clarity, the number that's by itself without a plus or minus, I'm going to put that first. So here I'm going to have 3x equals to 1 plus or minus the square root of 5. And then I can go ahead and divide everything by 3. Here, here, and here. So now 3 divides 3 to give me 1. That's what I want. I want 1x. Over here I get 1/3 plus or minus the square root of 5 over 3. And again, that's two different answers. 1/3 plus square root of 5 over 3, and separately 1/3 minus square root of 5 over 3. And these are our results. Notice how each one of these problems I'm writing out every step that I do. Taking a root, plus or minus, adding, dividing, and then I get my result. This is called showing your work. In this class, part of what we're doing here is learning how to organize our thoughts and show our work. We are learning how to get this answer, but that's not all we're learning. We're also learning the individual steps that it takes to get there. And I need to be able to see that you know how to do those. So in your homework, in your exams, and anything else that you turn in, you're going to be sometimes asked to show out a problem written out. And this is what I'm expecting you to do, to be able to write out individual steps. If you could do from here to here in your head, that's awesome. That's great. But that's not the only thing that I need to see that you can do. I also need to see that you know how to write down these steps correctly. If you can go from here to here in your head and write down the answer, that's great. But that's only half the answer that I'm looking for. The other half is the individual steps that it takes to get here. In other words, if you just write this answer, you're missing, how do I say this? If you only write down this part, you're missing part of your answer. This is also part of the answer. Right? So keep that in mind. As you're practicing doing these problems, if you can do some of these things in your head, that's good. But that's not going to show me these individual steps. You need to be able to write these down. Now, one issue with this technique is what seems a little bit limited. Because, yeah, okay, I can solve as long as I have x squared equals to something, or 3x minus 1 squared equals to something. Yeah? I can solve as long as I have a square equal to a number. But what if I don't have that? After all, if I look back to the first problems that I had in this section, that's not what my problems usually look like. I usually have x squared plus 5x plus 6, or 3x squared plus 5x plus 12. My problems don't usually look like something squared equals something else. So yeah, this technique is nice, but, well, it's kind of limited. It won't work for every other technique, right? It won't work for every other kind of equation. It only works for the ones that look like this. Well, actually, no. It is a lot more capable than just things that look like this. This requires another little bit of work called completing the square. It's true. If I have something that looks like this, x squared plus 5x plus 8 is equal to 0. Extracting the square won't work here. Why not? Because of this extra term here. I can use extracting the square as long as I have something squared equals to a number. If this was gone, sure, I could go ahead and extract the square. I could just move the negative 8 over here, and then x squared equals to negative 8, and it would look just like one of these. But having this extra term here means that I can't just extract the square. I don't just have something squared and a number. This one gets in the way. Completing the square is a way of rewriting our expression on this side so that it looks more like the expressions that we have over here. So completing the square, thankfully, isn't a very long process. And in fact, it's a very procedural kind of process. It's a very procedural kind of technique, meaning there's some steps that you take, and as long as you remember the steps to take in what order, it always works out nicely. Right? So here are the steps to complete the square. We're not going to solve the equation just yet. We're simply rewriting the equation. All right, so the first step is you're going to take the first two terms, leave them by themselves. We're going to put them in parentheses. And in fact, I'm going to change one of these numbers because the very first example I want to have it work out really nicely. I'm going to change this to a 4. In the next example, I'll use a 5 there. All right, so the first step is take the first two terms and bunch them together. I'm going to put parentheses around them. You don't have to, but I'm going to go ahead and do that for the visual. And then I'm going to take this other number, and there's two things you can do with it. You can either move it off to the side so you can have it plus 8 on the outside of the parentheses, or you can subtract it over to this side. Either one will work, so I'm just going to go ahead and do the first one. If you wanted to say, okay, let me subtract 8 over to this side, that's fine too. But here I'm going to go ahead and do it this way. Take these two terms, lump them together, leave this one separate off to the side. Okay? All right, now the next thing you want to do is you're going to want to take whatever number's in front here and factor it out. Now in this case, there's just the number 1 here. Okay, so no big deal, it's just the number 1. Here, I'm going to write the number 1 right here, just for the visual. What I'm going to do is I'm going to take this number and factor it out. So there's the number 1 out here. And when you factor out a number, everything in the parentheses is going to be divided by that number. Well, since that's the number 1, it's not really going to change much. Dividing things by the number 1, in fact, doesn't change them at all. In the next example, we'll have another number here. It won't be just the number 1, in which case you'll see things a little bit change a little bit more. Okay. All right. So now the next step is the key to making this look like one of these. We're going to take this number, we're going to cut it in half, and then we're going to square it. And we're going to do what now? We're going to cut it in half, then we're going to square it. So half of 4, well, that's the number 2. Oh, but now take that number 2 and square it. Okay, when I square 2, that's the number 4. So that's going to go right here, plus 4. But now you'll notice that I've just changed my problem. It's a completely different problem now. Yeah, x squared is still x squared, and 4x is still 4x, and 8 is still 8, but now there's an extra plus 4 here that just kind of magically appeared. Well, that means I changed my problem. Okay, well, I can't have that. I don't want a different problem. I wanted to solve this one up here. Oh, okay, so to balance out that plus 4, I'm going to use a minus 4. I'm basically going to say, you know what? I'm going to just cancel out what I just did. So I'm going to say minus 4 right here. Plus 4 minus 4. It's almost as if nothing had happened, right? 4 minus 4 cancels out. You say, okay, so then what's the point? Why did I just do that if it's going to go away? Well, it would go away if I let them cancel out. But I'm not going to let them cancel out. I'm going to leave them both there. And now I'm going to take these and lump them together. Meaning, yeah, this plus 4 and this minus 4, if I leave them next to each other, okay, that's going to be 0. I'm not going to leave them next to each other. I'm going to write this plus 4 in here, and I'm going to take this minus 4 and send it out to be out here with this 8. Like that. Notice this all simplifies out very nicely now. Here, this can be factored. What two numbers multiply to give me 4 and add up to give me 4? Oh, well, that would be 2 and 2. So this factors as x plus 2 times x plus 2. Here, 8 minus 4, well, that's negative 4. That's positive 4. And notice now, x plus 2 times x plus 2, I could just write that as x plus 2 squared. I haven't solved anything, but notice that I've taken my problem and rewritten it in a way. Now I can extract the square, because now I have something squared and a number, which means now I can extract the square. So at this point, we have now completed the square. So now let's take this and solve by extracting the square. Let me leave that square where it is, but let me go ahead and subtract the 4 over to the other side. So that'll be x plus 2 quantity squared equals negative 4. Now let me take a square root on both sides. Remember, plus or minus. Here I'm taking the square root of a 4, which is 2. Oh wait, no, I'm taking the square root of a negative 4. Okay, well that'll be imaginary. That'll be 2i. So plus or minus 2i. Here, the square and the square root, that's just going to give me x plus 2. And now we're almost done. Let's just get rid of that plus 2 so that we can get our x by itself. So that's going to be minus 2 on both sides, and that'll give me x equals 2. Let me put the negative 2 first, plus or minus 2i. And these are our solutions. Note there's 2 of them, negative 2 plus 2i and negative 2 minus 2i. So here, it takes a bit of extra work, but we can go ahead and rewrite any quadratic equation by completing the square. Once we've completed the square, then we can extract the square. Notice that this, we wouldn't have been able to factor. What two numbers multiply to give you 8 and add up to give you 4? I can't think of any. Right? But we don't have to. We don't factor it. We can solve this way. Let's see that again. Completing the square and then extracting the square. So here we're going to solve the quadratic equation. 2x squared plus, let's go with 20x plus 1 is equal to 0. All right, so to complete the square, take the first two terms and bunch them together. I'm going to write that as 2x squared plus 20x. I'm going to leave a little space here because I'm going to add some stuff in there later. And then a plus 1 off to the side. Again, some people like to subtract 1 over to the other side. Other people just push it over and leave a little space there. Either one's fine. Okay. Take the first two terms, bunch them together. Take the third, that constant, push it off to the side. Now, take your lead coefficient, whatever number's right here, and factor it out. So it's going to be a 2. Now, since I factored out the number 2, that means all the stuff in the parentheses gets divided by the number 2. Okay, so that's x squared plus 10x. That doesn't affect the 1. Only the stuff in the parentheses. Notice, this is still 2x squared plus 20x plus 1. Nothing's really changed other than the way we've written it. All right, take the first two terms, bunch them together. Take the lead coefficient, factor that out. Now, we're going to take that number in the middle, cut it in half, and then square it. Okay, so half of 10 is 5, but then square 5, well, that's 25. All right, half of 10 is 5, square 5 is 25. But I can't just add 25. That's going to change the problem. So I'm going to subtract 25 as well. Here, if I let those cancel, well, then they would cancel. And I'd be back to the original problem. But I'm not going to let them cancel. I'm going to write this way. That's going to be x squared plus 10x plus 25. That's going to stay in the parentheses. But now, this is going to come out. So I have minus 50 plus 1 equals to 0. At this point, you say, whoa, hold on. Minus 50. Where'd 50 come from? Negative 25 is in the parentheses. Notice that everything in the parentheses is being multiplied by 2. While it's still in the parentheses, well, then that 2 is just out there. But when I move it out, then that number out here will no longer be multiplied by the number 2. Okay, well, it was being multiplied by 2. Should that change? Okay, no, it shouldn't. Okay, so then we're explicitly going to write it as being twice as big. In other words, yeah, everything in the parentheses is being multiplied by 2. So if I'm going to bring it outside the parentheses, well, I can't forget that it's multiplied by 2. So let me multiply by 2 to make sure I don't forget. Right? Here, the 2 times negative 25 is negative 50. So when I write it outside, I'm going to write it as negative 50. All of these are still being multiplied by 2, so I can just leave them the way they are. So now this gets factored. There's a 2 out there. That's going to be what two numbers multiply to 25 and add up to 10? Well, that's going to be 5 and 5. Negative 50 plus 1 is negative 49. And now here I can even write that as 2 times x plus 5 squared minus 49 equals to 0. And now we've completed the square. So now we can extract the square. Okay. To solve, we're now going to go ahead and add 49 to both sides. That's going to go away. That's going to give me 2 times x plus 5 squared equals to 49. Now, I want to take the square root of both sides, but I can't do that just yet because there's a 2 in my way. All right? In every other problem I've seen, whenever I take a square root, it's because it's something squared, something squared, something squared. There was no other number out here. Okay, well, that's simple enough. Let's just go ahead and divide that out to the other side. If I divide both sides by 2, it looks like that, and that's going to give me x plus 5, quantity squared, is equal to 49 over 2. Now I can take the square root. It's going to be square root of both sides, plus or minus. Okay. That's going to give me x plus 5 is equal to plus or minus. I know the square root of 49. That's just 7. Square root of 2, okay, that's going to stay square root of 2 because I can't take the square root of 2. I'm going to go ahead and rationalize this. I'm going to go ahead and multiply top and bottom by the square root of 2. I don't want a radical in my denominator. Why not? Because in a few sections, we're going to start graphing this stuff. And when we graph stuff, we have to be able to get at least a decent approximation of where it is. I don't know about you, but I don't know how to divide by the square root of 2. So what I'm going to do is I'm going to go ahead and rationalize it. I'm going to multiply by the square root of 2. That way, square root of 2 times square root of 2 is square root of 4. Oh, and I know the square root of 4. It's the number 2. 7 times root 2, okay, well that doesn't simplify, but at least I don't have a radical in my denominator anymore. We rationalize not because this is wrong, but because in a few sections we're going to need to graph. This is going to be hard to work with. This will be much simpler, as we'll see. And finally, let's get rid of that plus 5 with a minus 5. So that's going to give me my result. X is equal to negative 5 plus or minus 7 root 2 over 2. Just like that. And these are my solutions. So give that a try. Go ahead and solve. Oh, let's go with this. 4x squared plus, let's say, 16x plus 3 is equal to 0. Go ahead and complete the square and then extract the square. Are there other ways to solve? Sure, but right now that's what we're practicing. So go ahead and pause the video and go ahead and solve this by first completing the square and then extracting the square. Once you're done, go ahead and unpause the video and we'll go through it together. All right, so let's go through this one. First, we're going to complete the square. Let's start off by taking these two terms, bunch them together. So 4x squared plus 16x. I'm going to go ahead and put parentheses around those, leave a bit of space, and then I'm going to have the plus 3 on the outside is equal to 0. Okay? I'm going to take that number in front and factor it out. So that's going to be 4 times x squared plus 4x plus 3 equals to 0. And notice that when I factor out the 4, the stuff inside the parentheses is being divided by 4. You can always double check that. Look, 4x squared. Okay, fine. 16x. Yeah, that's right. On the outside, I have a plus 3, which is that plus 3 there. All right? You can always double check to make sure this is correct if it distributes back out to give you what you started with. So now I'm going to take this number, I'm going to cut it in half, and then I'm going to square it. Half of 4 is 2, and then square root 2 is 4. But then a minus 4 to balance out that plus 4. I can now write this as 4 times x squared plus 4x plus 4. This minus 4 is going to get pushed to the outside of the parentheses. But notice that minus 4 is being multiplied by that 4. So when I pull it out, we're going to write it as a negative 16. Like that. Okay. Again, you can always check to make sure that this is correct by comparing it to the original equation. That's 4x squared. Okay, good. That's 16x. Okay, good. That's plus 16. Oh, but then minus 16 cancels it out, yeah? And then plus 3 is that 3 there. So yeah, all of this is the same as all of this. 4x squared plus 16x. That 16 and that minus 16 give me 0, so those go away. And then that 3 is that 3 there. Okay? So this is still correct. Finally, I can go ahead and factor this out just a bit more. Hey, look. What two numbers multiply to give me 4 and also add up to give me 4? Oh, that's 2 and 2. So x plus 2 times x plus 2. Negative 16 plus 3 is negative 13. And that's going to equal to 0. Here we can write this as a square. X plus 2 times x plus 2. That's the same as saying x plus 2 quantity squared. Minus 13 is equal to 0. And there we go. We completed our square. So now we can go ahead and extract our square. We need to move all of our things over this way and leave just the thing that's being squared by itself. All right, so let's go ahead and start with that. We can add 13 to both sides. That goes away. And that'll give us 4 times x plus 2 squared is equal to 13. Let me get rid of that 4 as well. I need the thing that's being squared to be by itself, no other numbers, and that includes the number in the front. So that's going to give me x plus 2 squared is equal to 13 over 4. And now I can take the square root of both sides. When I take the square root of a number, there's two versions. There's a positive and a negative. So here that's going to give me x plus 2 is equal to plus or minus the square root of 13. Well, that's just the square root of 13. But here I do know the square root of 4. That's just the number 2. Looks just like that. And finally, I can go ahead and subtract the 2 over. In the previous problem, you saw I rationalized the denominator. Here it's not necessary. The denominator is already a rational number, right? Over here we rationalize because there was a square root on the bottom. We don't want a square root on the bottom. Here, the denominator is already a whole number, so we're good with that. We're going to leave it that way. So here, let's go ahead and subtract our 2. Subtract our 2. And that's going to give me x is equal to negative 2 plus or minus the square root of 13 over 2. And that's our result. Completing the square is a useful technique for reasons other than just solving quadratic equations. Here, to go from this to this is useful for solving equations. It'll be useful for a few other things down the line. In particular, it'll be useful when we talk about graphing quadratics, quadratic conics. But for now, this is one reason why it's useful. But we'll see this again, turning something like this into something like this. For those of you who go on past algebra into pre-calculus and eventually calculus, this will be used for a few other things as well, namely rewriting denominators so that they fit integral forms. That's something that comes much later. Now, the nice thing about completing the square is also one of the more annoying things about it, and that's that it's very procedural. There's a step number 1, step number 2, step number 3, step number 4. All right? You take the first two terms, bunch them together. You factor out the lead coefficient. You take this number, cut it in half and square it. And then you separate these out by factoring and combining. 4 basic steps. Combine the bunch together the first two terms, factor out the lead coefficient, half then square, and then simplify. That's nice because you know exactly what to do each time. It's always the same 4 steps. It's also somewhat annoying because, well, you're always doing exactly the same thing. Well, we can actually take advantage of that. In math, whenever you see something keeps happening over and over again in the exact same pattern, what you try to do is you try to exploit that pattern and see if we can't simplify it, see if we can't make things any more automatic. That's where formulas come from, or at least that's one place where formulas can come from. So here, let's take a look at one more method for solving quadratics. And the way we're going to find this method is I'm going to go ahead and solve quadratics. You say, well, you've already solved a few quadratics. Well, I don't mean specific quadratics. I mean all of them. What do you mean by that? Well, this is what quadratics look like. They look like ax squared plus bx plus c is equal to 0. This is what every quadratic equation in the world looks like. All right? That's the definition of a quadratic equation. And yeah, you can rewrite these things in some different orders, but you could always rewrite them so that they look like this. If it looks like this, or if it can be rewritten to look like this, then it's a quadratic equation. If not, then it isn't. So this right here represents every quadratic equation you could ever see. Well, I already saw that using the extracting the square technique, I can solve any quadratic equation. Well, then shouldn't I be able to solve this one too? You say, well, yeah, but there's no numbers here. So what? I still know the techniques. Let's see here. Whenever I solve a quadratic equation, the first step is to take the first two terms and bunch them together. So let me do that. I don't need to know what the numbers are to just write parentheses around them. Okay, so no big deal there. You say, well, yeah, but that was easy, right? The first step is to take the first two terms and put parentheses around them. Take that third number and move it over to the side. Well, yeah, but that's easy. You don't need to know what the numbers are. You just put parentheses and then move that one over there. Okay, well, what was the next step? Well, the next step was to take the number in the front and factor it out. Well, I don't need to know what a is to write it on the outside of the parentheses. Oh yeah, but now I need to know what a is, right? And I need to know what b are. I need to know what these numbers are, because of course the next step was, once I factor out the number, the 4, I'm supposed to divide these by that number, right? 4 divided by 4 gave me 1. 16 divided by 4 gave me 4. If I don't know what those numbers are, I can't divide. Well, sure I can. A divided by a is 1. Okay, fine. But what about b divided by a? Well, it's b over a. You say, well, what is b over a? It's a fraction. There we go. I divided by b by a. The fact that I don't know what those numbers are doesn't mean I don't know what fractions are. Okay, fine. But, well, that's cheating, right? You don't know what those numbers are. So what? I know how to divide b by a. I've just done that. And look, if I distribute this is going to be ax squared. Here, these two a's would cancel out, leaving me bx plus c is equal to 0. So technically, nothing's changed. Okay, so now what? Well, the third step was, you're going to take this number here, you're going to cut it in half and then square it. Well, obviously, I can't do that if I don't know what those numbers are, right? Well, actually, no, I can do that. Let me take b, and let me do that off to the side over here. If I take b over a, I'm supposed to cut it in half. Well, how do I cut it in half if I don't know what it is? Well, let me multiply by 1/2. That's what it means to cut something in half. It means to take half of it. 1 times b is going to be b, and 2 times a is going to be 2a. And there we go. I've just cut the number in half. b over a, if I cut it in half, I get b over 2a. And then I need to square it. Oh, well, I know how to square. b times b, well, that's going to be b squared. 2 times 2, well, that's going to be 4. a times a, well, that's a squared. All right, b squared, 2 squared, a squared. Okay, so if I take b over a, if I cut it in half and then square it, I get that number right there. So that's going to be plus b squared over 4a squared. Oh yeah, but whenever I add something, I'm supposed to subtract it, right? So minus b squared over 4a squared. Okay, so now what? Well, now I'm supposed to keep these together. Okay, so leave the a right there. Let's have x squared plus b over ax plus b squared over 4a squared. And then this is supposed to come to the outside. Oh yeah, but when it comes to the outside, I'm supposed to multiply it by that number there. Well, how do you do that? Well, let's see. I have negative b squared over 4a squared. That's that number there. And when it comes to the outside, I'm supposed to multiply by that a there. Okay, well, remember, a squared means a times a. So one of these a's can divide that a right there. All right? If I have negative b squared over 4a squared, remember, a squared means a times a. So if I multiply by that a, one of these divides one of those, and I just get negative b squared over 4a. So when this comes out, basically just loses its square. So that's going to be minus b squared over 4a plus c is equal to 0. It's amazing how far we can get without knowing what those numbers are. We can go further though. All right. Whenever I'm completing the square, the next thing I'm supposed to do is I'm supposed to factor that. And I'm supposed to combine those two numbers. Okay, well, let's do that. I'm supposed to factor this and combine those two numbers. Well, how do you factor this? Well, I need to find two numbers that when multiplied together give me this, but when added together give me this. You know, believe it or not, we already have that. That's this number over here. If I have b over 2a times b over 2a, it's going to add up. That's going to multiply to give me b squared over 4a squared, because that's how I got b squared over 4a squared in the first place. But since b over 2a is half of b over a, if I add b over 2a plus another b over 2a, that's going to give me 2b over 2a. And since the 2's divide away, that'll give me just b over a. So here, this is going to be a times x squared. Oh, sorry, not squared. A times x plus b over 2a times another x plus b over 2a. At this point, if you're having a hard time with that, you can pause the video and multiply these two back out. If you multiply these two together, you'll find out that you get exactly this. You'll get x squared plus ba over x plus b squared over 4a squared. Right? Say, okay, well, that factors into these. But you're supposed to combine those. How do you combine those? Well, let's add them. After all, they're just regular numbers. You say, well, I don't know what they are. So what? We can still add them. Let's say I have negative b squared over 4a plus a c. Well, that is a fraction. And whenever I'm adding fractions, I need a common denominator. So here, let me give this a denominator of 4a. That way they have the same denominator. But whatever I do to the bottom, I have to do to the top. So let me multiply the top by 4a. Okay, so that'll be negative b squared over 4a plus, I'm going to put these in alphabetical order just because I feel like it. I'm going to put the a in front of the c. So I'm going to write this as 4ac over 4a. And now I can add those because whenever I add fractions, when the denominators are the same, all I do is combine the numerators. So I can write this as negative b squared plus 4ac over 4a. Okay, so right here, if I take negative b squared over 4a plus c, I get negative b squared plus 4ac over 4a. So that's going to be plus a negative b squared plus 4ac over 4a. And of course, since these two are the same, I can write them as a square. I can write this as a times x plus b over 2a squared plus negative b squared plus 4ac over 4a is equal to 0. And there we go. We've completed the square. Isn't that amazing? But you know what? Since we've completed the square, it won't take much more effort to extract the square. In all the previous examples, completing the square is the hard part. Once you've completed the square, extracting the square is just move this to the other side and then take a square root. So let's do that. Let's go ahead and move this over to the other side. I have plus that number, so let me subtract that number. All right, that's plus a number. So let me subtract that exact same number to make it go away. But of course, whatever I do to one side, I'm going to do to the other side. So over here, I'm also going to subtract that number. Okay, so now that's going to leave me an a times x plus b over 2a squared. This is by itself. This is gone now. Is equal to negative that number. I have negative a negative. That seems redundant. Let me write that as a positive. Negative of a negative, that's a positive b squared. And then here, let me distribute that negative to this one over here. So there's a negative on the outside. Let me go ahead and distribute. Negative of a negative makes that a positive. Negative of a positive makes that a negative. So I have a times x plus b over 2a quantity squared is equal to b squared minus 4ac over 4a. Okay, here, let me get rid of that a too. Whenever I take a square root, I need just this part by itself. So let me divide this by a, and let me go ahead and divide over here by a. All right. I have an a in the denominator here, and I have an a in the denominator here. Here, let me write it this way. I have 1 over a and 1 over a. Same thing on both sides of the equation. Here, this a divides that a, and that's going to give me just x plus b over 2a squared. Over here, I have b squared minus 4ac times 1. Well, multiplying by 1 doesn't change anything. But in the denominator, 4a times another a, well, a times a is a squared. So now let me get rid of that square by using a square root. If I take a square root of both sides, now remember there's two square roots, a plus and a minus. That's going to give me x plus b over 2a. All right, that square is gone now. Equals to plus or minus. Now, I can take the square root of the top and the bottom separately when this happens, right? Over here, when I take the square root of a fraction, I take the square root of the top. Separately, I take the square root of the bottom. Notice right here, I can actually take the square root of the bottom. I can take the square root of 4. That's just the number 2. And I can take the square root of a squared. That'll leave me just the a. Now, the numerator is a lot more complicated, so I'm not going to worry about that. Let me just leave that underneath the square root. So I get x plus b over 2a equals equals plus or minus the square root of b squared minus 4ac over 2a. And now we're practically done, because of course I need the x by itself, so all I need to do now is get rid of this number. So that's going to be minus b over 2a, and same thing on the other side, minus b over 2a. To make things clear, I like to keep this in front. The plus or minus goes after the single term there. So here I have x is equal to negative b over 2a, and then I have this expression, plus or minus the square root of b squared minus 4ac, also over 2a. And there we go. There is our set of solutions. Some people like to note that since you have a common denominator there, you can always add those together. And that's fine. You can always write this as x is equal to, since you have a common denominator, just put that all together in one numerator and then have a single common denominator. So you can write this as negative b plus or minus the square root of b squared minus 4ac all over 2a. You can write that either way, either as two separate fractions, both with a 2a in the denominator, or as one big fraction where everything's divided by 2a. Either one's fine. So this is the solution to every quadratic equation you could ever imagine. Notice we never even needed the numbers. We didn't need to know what a, b, and c were, because extracting the square and completing the square are procedural because they always work the same way. We know we can do it regardless of what those numbers are. This is called the quadratic formula. And the quadratic formula is the result of completing the square and then extracting the square. The quadratic formula is a third way of solving a quadratic equation. It's the last thing we're going to see here. The quadratic formula has a huge advantage and also a huge disadvantage. In fact, they all do. We've seen 3 different techniques. The first technique that we've seen is one that we've seen way before this class ever started, and that was factoring. Factoring has a single advantage, namely that it is very short and sweet. Factoring is the shortest way of solving most quadratic equations. It is short, it's simple, and it's easy to use. The disadvantage of factoring is that it doesn't always work. If your numbers are small and simple and easy to work with, then yeah, it works beautifully. It's the best way to go. But if your numbers are either very large or very complicated to work with, like fractions and square roots, then it's not going to work. So factoring is the best technique as long as your numbers are small and simple to work with. Extracting the square, completing the square, that one has a huge advantage in that it always works. No matter what you do, it will always work. It has another secondary advantage that it records every step that you do, meaning you have a procedural 1, step 2, step 3, step 4. If you make a mistake anywhere along the problem, you can always double back and figure out where that mistake was. If you have a problem that's written this way, if your answer is incorrect, if you go back and double check and see, well, what happened? Oh, you can always find where your mistake was. Oh, I made a mistake here. I put a plus instead of a minus or something like that, right? Somewhere along the line, you'll find your mistake. It has the disadvantage, however, that completing the square and extracting the square tends to be kind of long. Notice that's a lot longer than factoring was. This third technique, called using the quadratic formula, has a huge advantage in that it's a formula. It's something you can memorize. If you memorize this formula, as long as you memorize it correctly, it's going to work. It has a disadvantage, though. In fact, 2 small disadvantages. One is that you pretty much either get it right or wrong. Either it's the correct formula, meaning that's it, you got it right, or you made a small mistake, in which case it's wrong, right? There is no step-by-step procedure. There is no individual steps where you can double back and find your mistake. Either it's right or it's not. The other small disadvantage of this is that, well, we'll see here in just a moment, the arithmetic. Here, because it's a formula, you're not going to rely on algebra like you did in the previous example, but you're going to rely on arithmetic, which means there's going to be a lot of numbers and a lot of simplifying to do. There is no best way. Each technique is going to be useful in different cases. If you have very small, very simple numbers, factoring is clearly the way to go. If you have something that's a little bit larger, but if it's something written in a square or something where a completed square can be easily found, then completing the square and extracting the square is going to be the fastest way to go. However, if you have something where your numbers are very complicated, even though it is going to require a lot of simplifying, the quadratic formula may be simpler. Right? There is no best one. They're all useful at different times. So let's go and wrap up our section by looking at a couple of examples of using the quadratic formula. All right, so let's see here. Let's say we're going to solve the equation, let's go with 2x squared plus 5x plus 9 is equal to 0. Okay, so here, this number represents, this number is represented by the symbol a. In our quadratic formula, anytime you see a, it's going to represent whatever number is in front of your x squared. B is going to, in fact, let me write this as a minus 5. B is going to represent whatever number is in front of your x, and C will represent whatever constant number you have, the number with no variable. Note that the numbers include whatever sign they come with. So here that's a positive 2, that's a negative 5, and that's a positive 9. Okay? So what the quadratic formula tells us is if you have an equation, ax squared plus bx plus c equals to 0, then x is going to equal to negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2a. And we're going to substitute a, b, and c into the appropriate places. So anywhere I see an a, I'm going to plug in the number 2. Anywhere I see a b, I'm going to plug in negative 5. Anywhere I see a c, I'm going to plug in the number 9. Oop, go ahead and put a blank there. Just like that. All right, so now anywhere I see an A, I'm plugging in the number 2. Okay, so that's a 2 there and there. Anywhere I see a B, I'm plugging in negative 5. So there's a negative 5 there and there. Notice that's the negative of a negative. That negative comes from the results of our quadratic formula. That negative comes from the fact that that's a negative 5. So double negative will make that a positive here in a moment. And anywhere we see a C, we're going to plug in the number 9. So note, if we have not made any mistakes, this is our answer. But of course, now we simplify. So this is where it can sometimes be a little bit annoying because there's a lot of arithmetic here. There's no algebra, but all the arithmetic is in place. So let's go ahead and simplify. Negative of a negative, that's a positive. Here, 2 times 2 is 4. In the square root, though, we have a few operations, so we have to follow the order of operations. Parentheses always come first. Well, yeah, that's why we're looking in the radicals. These are being held together like if we had parentheses. Okay, so within these parentheses, within this radical, we have an exponent. Okay, so we handle that one first. So negative 5 squared. Now remember, negative 5 times negative 5 is positive 25. Don't make the mistake of saying a negative times a negative is a negative. That's a positive. So we square first. Okay. Parentheses, exponents. Next comes multiplication, division. Okay, well, inside the square root, there's no division, but I do see some multiplication. So 2 times 4 is 8. 8 times 9 is going to be 72. So that's going to be 5 plus or minus root 25 minus 72 all over 4. Okay, so now once we've multiplied, once you finish multiplying, we can go ahead and subtract. So let's see, 25 minus 72, that's negative 47. So that's going to give us 5 plus or minus square root of negative 47 over 4. Okay, let's see, negative 47. Can we factor 47? No, we can't factor 47, but we do have a negative here, so that does mean we're going to have to separate that. That's going to be 5 plus or minus the square root of negative 1 times 47, all over 4, which is the same as saying 5 plus or minus the square root of negative 1 times the square root of 47 over 4. And here we know the square root of negative 1 from our previous section. That's the imaginary unit. That's I. So here that's going to be 5 plus or minus I root 47 all over 4. Now remember, whenever we're dividing a complex number by a real number, we divide each of these and simplify if we can. So that's going to be 5 over 4 plus or minus. And then separately, we have I root 47 over 4. I root 47 over 4. And now we check if this can be reduced. 5 over 4, no, that doesn't divide. And same thing here, nothing here divides. So that's as far as we can simplify. So these are our solutions. 5 over 4 plus I root 47 over 4, and 4 over 5 minus I root 47 over 4. Notice that this is, well, it's fairly long, but it does give you a nice result, and certainly factoring would not have been possible with an equation like this. So go ahead and give this a try. This will be the last problem for the section. Use the quadratic formula to simplify and solve the equation. Go ahead and give this a try. Solve. Oh, let's have you try 3 times x squared minus 4x plus, oh, let's say 12 is equal to 0. Okay. Go ahead and use the quadratic formula to solve this and simplify all the way down until you get a complex number or a real number. In the end, if it's a real number, well, then you get a real number. If it's a complex number, you'll get real plus or minus imaginary. All right, so go ahead and give that a try. Whenever you're done, unpause the video and we'll go through it together. All right, let's go through that together. Here we have A is equal to 3. B is negative 4. That includes whatever sign it comes with. And C is 12. One thing people will make a mistake on is they'll include the variable. B is not negative 4x. It's just negative 4. Same thing here. A is not 3x squared or even 3x. It's just 3. It includes the sign, but never the variable. So here we have x is equal to negative b plus or minus the square root of b squared minus 4 times a times c. And then all of this is divided by 2a. Make sure you have this memorized correctly. The biggest mistake people will make when using the quadratic formula is at the very beginning. They'll forget a negative here, they'll forget a plus or minus here, they'll forget a square, a 4, or a 2. Some small part of this will be forgotten, and if even one little tiny piece is forgotten in a formula, the whole thing's wrong. That's one of the biggest annoyances about a formula. There is no half right. It's either the correct formula or it's not. So let's go ahead and substitute in our values here. Anywhere I see an A, I'm plugging in the number 3. So that's going to be 3 here and 3 here. Anywhere I see a B, I'm going to plug in a negative 4. So that's negative 4 here and negative 4 here. And anywhere I see a C, I'm going to plug in the number 12, which is that number there. So now we need to simplify. Okay, well out here, double negative makes that a positive. And here 2 times 3 makes 6. So nothing too big there. But now in the radical, we have some stuff to simplify. First, exponent. Negative 4 squared, that's a positive 16. Negative times the negative is a positive. Minus 4 times 3 times 12. Okay. Now, after exponents, I'm going to do all my multiplication. Okay, so 3 times 4 is 12. 12 times another 12, that's 144. So that's going to be 4 plus or minus 16 minus 144 under a square root all over 6. And now I can go ahead and subtract that. 16 minus 144, that's what, 128? Oh, but that's a negative since you're subtracting the bigger number. So 128 over 6, just like that. And now there's, in fact, there's quite a bit I can do to simplify this. So here that's going to be 4 plus or minus the square root of, now there's a bunch of numbers I can write that multiply together to give me 128. All right, I could do 1 times 128. I could do 4 times 32. But what I want is I want the biggest number that I can get that's a perfect square. That's a factor of 128. So here I'm going to write this as negative 1 times 64 times 2. Yeah, I know that there's other numbers that multiply to give me 128, but here 64 is the biggest factor of 128. That is a perfect square. I can take the square root of 64. Okay. All right, so now let me go ahead and keep simplifying here. That's going to be 4 plus or minus. I can separate this out into 3 different radicals. Like that. And now I can take these 2 radicals. The square root of 2 I can't simplify anymore, but I can simplify the square root of negative 1, well that's I. The square root of 64, that's 8. And the square root of 2 is just 2, the square root of 2. That doesn't simplify anymore. But then the whole thing is being divided by 6, like that. And now remember, whenever you have a complex number, that is a complex number, divided by a real number, we separate and simplify. So that's going to be 4 over 6 plus or minus. That's going to be I root 8 over 2. I times 8 root 2 over 6. And now those can be reduced. Right? 4 over 6, that's the same as 2 over 3. Plus or minus, and then 8 over 6 can also reduce to 4 over 3. So that's going to be 4 root 2 over 3. And then that's our imaginary part. So it's being multiplied by an imaginary unit. And these are our results. 2/3 plus or minus 4I root 2 over 3. And there we go. So there is our problem. And here are the steps to give us our solution. All right, so that is it for this problem, and that is it for the section. If you have any questions, make sure you make a note of them, write them down, and you know how to reach out to me. Go ahead and send me an email or talk to me during our next meeting. All right. I hope you all have a nice day.